Hi, math lovers. Welcome to notes number 9, lesson P5 of the prerequisite chapter of our algebra and trigonometry text. And we're talking about rational expressions today. I have two problems I want us to work through. The first is a complex fraction, and the second involves finding common denominators. I want you to look at this complex fraction. Notice we've got a fraction in a fraction. That's a definition of a complex fraction. I always think if Dr. Seuss were to write a math book, it would be about a complex fraction. There's a fraction in my fraction. Oh, what was my reaction? Anyway, so that's as far as he would get. Take a look at these. I'm going to show you a shortcut. Mathematicians, we love shortcuts. Look at these denominators. You could go ahead and simplify your numerator, simplify your denominator, and then go ahead and divide. That's fine. You can do that. But I want you to think about it maybe a different way. Think about these four. Let's make this one a fraction too. Think about these four fractions. What would be the common denominator? You've got 4, 2, 1, and x. What's the common denominator? Right, 4x. So 4x is your common denominator. So what if I took 4x and I multiplied everything by 4x? Okay, so I'm going to write this all out. Take me just a second to do that. All right, you should write this all out too, just to make sure you don't lose anything. That would be terrible. All right, so 4x. So what I'm going to do now, every single term in the fraction is going to be multiplied by the exact same thing, and that's why we're allowed to do this. You will notice that things are going to divide out. All right, so my 4's are going to divide out right here. All right, my 4's will divide out. My 2 is going to go into 4 2 times. This 1, well, that's really nothing, isn't it? And this x is going to divide out here. Look at what has happened. All of my denominators have, poof, disappeared, okay? So I'm left with, let's see, x, right? X and x, so x squared plus, let's see, plus 6x over 4x times 2, that would be 8x, minus 3 times 4, which would be 12, okay? All right, cool. Can I reduce that at all? Well, you might want to, I don't know, maybe somebody wants to see it as x times the quantity x plus 6 over, 4 times the quantity 2x minus 3. Maybe somebody would want to see it that way, but certainly you couldn't go any further. Either of those would be completely fine. But I want to draw your attention. What did we divide out here? All right, 4, 2, that's not a big deal. 1, not a big deal. But the x, we divided out the x here. Okay, so we need to tell our reader, hey, x is not equal to 0. X is not 0. It's not part of our domain. Okay, you can't forget that. That's very important. All right, if you don't have that, then you'll lose some points. Okay. Second problem we want to do today is number 67. This one's from your textbook. Stare at the problem, let it talk to you. Notice you've got 3 fractions, 3 totally different denominators. Or are they different? Are those denominators really different? So let me rewrite this. Let me rewrite this as, can't factor this denominator. Too bad. But this denominator I can. I can rewrite this as x times the quantity x squared plus 1. Oh, isn't that nice? Look at that. So think about the 3 denominators that you have there and what would be the common denominator. In order for me to add them together, I would need a common denominator. Notice there's no equal sign here, so I can't multiply anything through by that denominator to turn it into whole numbers. All right, so my common denominator here is going to be the product of these 2 terms, which is actually this third term, this third denominator that I have. So I'm going to go ahead and write those down. You should write them down too. Okay, here's the 1. Okay, so for me to go from this denominator of x to this denominator of x times the quantity x squared plus 1, I'm going to have to multiply numerator and denominator by x squared plus 1. And the second term, to go from this denominator to this denominator, I'm multiplying by x, so this is 2x. Okay, I'm a little worried about distributing that -1. I think it's a place people will mess up, so I'm going to go ahead and write it as one big fraction with my denominator, my new denominator right there. So that would be -x squared minus 1, I'm going to distribute the minus, plus 2x plus 1. Okay. Well, I could clean that up a little bit. The only thing I can do here is go ahead and take this -1 and this +1 and I can add them together. so that I am left with negative x squared plus 2x over x times x squared plus 1. And I know what you're thinking. I know exactly what you're thinking. You see that factor of an x in all of them, which is really great. And good for you. You're spot on. But let's do it in 2 steps so we don't lose anything. If I factor out an x from my numerator, I would have x times the quantity, negative x plus 2 over x times the quantity, x squared plus 1. And then it's safe for me to go ahead and divide those x's out. I'm not going to lose anything. I'm worried that kids are going to lose it, do it here and lose this x over there. So now I'm left with negative x plus 2 over x squared plus 1, much reduced from the original. I do have to make sure that nothing divided out along the process. Well, right here I divided out x's, so I need to tell my reader, hey, x cannot equal 0. Okay, so there is my final answer. My final answer is not just the simplified fraction, but it's also the domain. I'm including that domain in there. Don't forget that. Okay? Have fun with your problem set.